Hi again. We're going to do a little bit more of messing around with geometric series. We're going to come up with a general formula for a geometric series of the form sum I equal 1 to m, I equal m to infinity of a times r to the I. So just to point out, this is, remember, a times r to the m plus a times r to the m plus 1 plus dot, 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 right? Just keep adding bigger and bigger powers of r on there. And I want to see if I can come up with a general formula. So last video, we did an example where we started from I equal 1 to infinity of 1 over 3 ti, I think it was. And you notice the second approach, we changed the index of summation. And that's really the easiest way here to come up with a general formula. So that's what we're going to do. We're going to write this as the sum I equal m to infinity of a times r to the m times r to the I minus m. And of course, a times r to the m, there's no i's in that at all. So those are constant with respect to the summation. So I can factor that out and write that as a times r to the m, the sum I equals m to infinity of r to the I minus m. Now, what does this gain me? Well, let's look at what that sum looks like. Again, the sum is when I equals m, I get r to the 0, right? When I equals 1, it equals m plus 1, I get what? I get r to the 1, right? When I equals m plus 2, the next integer, I get r squared, and so on. That can be written as, let's make that darker. That can be written as, well, we've got the a r to the m times the sum I equals 0 to infinity of r to the I. So in general, when I change the index from m to 0, my I is going to change to I plus m, right? Because in the second thing, when I equals 0, I want it to be the same as I equal m over here. Okay, I'll let you think about that a little bit. Okay, but now it's in the right form, assuming the absolute value of r is less than 1. That's going to be a r to the m times 1 over 1 minus r, which is a r to the m 1 minus r. So in other words, let's rewrite this. So in other words, we've come up with a formula here. We have this is equal to a r to the m over 1 minus r, where m is the lower index of the summation and a is the constant being multiplied by that. So let's look at this example down here. So again, just like before, I'm going to rewrite that. I'm going to try and get it in the same exponent. So the same exponent is going to be to the I. So I get I to 4. I equals 4 to infinity. That 3 to the I plus 2, I'm going to rewrite as 3 squared times 3 to the I over 4 to the I. Now the 3 squared, which of course is just 9, can be brought out. And I get 9. And 3i over 4i is what? That's 3/4 to the I. So this is exactly in the situation we have above. What's my r? R is equal to 3/4, right? M is equal to 4. And A, if you want, is equal to 9. So this is equal to this here is equal to 9 times 3/4 to the 4th power over 1 minus 3/4 Of course, that can be simplified. That's going to be 9 times 3 to the 4th, that's 3 squared, that's 3 to the 6th over, let's multiply this, 4 to the 4th, I'm going to write that as 4 cubed and multiply the 4 through this denominator here, and I get 4 minus 3, which is 1, so it's 3 to the 6th over 4 cubed. And that's good enough. Okay.